Alright, so I only wrote these as for means, but I could plug in P instead of mu if I wanted to. What are our three options for what can go in the alternative part? So those are my three options. So we just talked about this. Where will I shade if it's greater than?
Right.
Where will I shade if it's less than? And where will I shade if it's not equal to? So how many tails are shaded here?
1.
How many tails are shaded here?
1.
And how many tails are shaded here? So if we talk about a two-tailed versus one-tailed, that's what we mean. Now, don't write this. If I make a terrible, terrible claim, like I think this class is really, really smart and they're going to have a really high SAT score, I'd be thinking like this, right?
I think that's a terrible.
No. You know what I'm saying? And let's say I totally mess up and y'all did terrible on your SAT scores, then it would look like this. Does that make sense how it can happen? So like, just because it's supposed to look like this, if I missed terribly, it can still look like this, but that's not going to happen very often. I would have just totally messed up from the beginning. Okay, I always get people who write, I don't have many people, I have some people who write these wrong. What does P stand for? Population proportion. Shouldn't have anybody who doesn't know that. What does P hat stand for? Sample proportion. Shouldn't have anybody in here who doesn't know that. We now have something called p-value. And if you mean p-value, don't write p equals.
Is it the shading area?
Yeah. So our p-value, and if you mean p-value, you literally have to write p-value, is the probability So this goes back to the beginning, where we started with the runner example. Theoretically, let's pretend hypothetically that I believe you. I'm going to go with what you say. If what you say is true, then this is how unlikely what just happened would actually happen. Or how unlikely it would be to actually happen. So the probability of getting a value at least as extreme which means that far from the mean or farther as the one observed So he claims to be a 5-minute mile runner. He ran once and ran a 5.25. The probability of that ended up being about 16%. So the probability of him doing that slow or slower, if what he claimed actually was true.
So, like, if we said 5, then less than 5, or looking at greater than 5?
Say it again.
Like, if he claims to run 5.
This is all based off of how we draw the curve. So if how we drew that curve is correct, this is how unlikely his statistic would have been to be that far away. Like the whole claim was that he ran a 5-minute mile. That's what we based everything off of. So the likelihood of him running as slow as 5.25, just by chance, is about 16%.
That's the unlikelihood?
that's how likely it would be for him to run that slower. So this is where I kind of stopped on that last worksheet where we got to 0.0062. So what we are looking for here is we want to see if what you say is really true, this is how likely that scenario would be to happen. So if this scenario was really, really, really unlikely to happen, what's actually probably the case? So think back to the runner.
That he's not true.
That maybe he really can't run a 5-minute mile. So maybe the claim really isn't true. So that's the whole thing that we're coming back to while we're doing all this. So an outcome that would very rarely happen if the claim were true is actually good evidence that what? The claim is not true. So if we got something like 0.0062 for him, okay, maybe it's just the fact that you really can't run a 5-minute mile. So don't write what I'm writing off to the side because you're not going to have room to do it and it's not going to make sense to this. If we had a small p-value, right, it was very, very unlikely for him to run that slow, what would it mean about this? If it were less than 1% chance that he actually ran that slow, if this were true, what does that actually mean? That this is wrong.
He said
If there were a 1% chance that he were going to run that slower, if this were the truth.
Does that mean he's so true?
If it's only going to happen 1% of the time, it doesn't seem very likely. So when we made our graph, if 5 minutes were here, and he ran something so slow that it were way over here, that shaded area is very small. So if that shaded area is very small, the likelihood of that happening is very small.
Then doesn't that mean he was telling the truth? Oh no, it's that he runs at least that.
That means we are going to reject the null hypothesis.
You're saying he runs at least what's over there?
That means he runs. He is not.
He can't run faster.
Yeah. Okay. So this is back to court case here. If we have a whole lot of evidence, we're going to reject the fact that you are innocent. If we don't have much evidence, then what? Are they innocent? This is very, very, very specific. And I'm pretty sure they don't say this in biology here. I don't know that. You never, ever, ever, ever accept the null hypothesis. That is statistically incorrect to ever accept the null hypothesis. Do what your biology teacher says. It is with the context of that classroom, and that is fine. But for our class, you will get it wrong every time. So this is like saying, think about it, is where I started. Are you ever going to say that means they are innocent? No, that just means we didn't have enough evidence to convict them. And that's the way we think about it. So this would be because we had evidence of so we had so much evidence that he was a lot slower than that we would actually reject this claim. Which again here would be we do not have enough evidence of. So your conclusion conclusion is going to be one of these two fill-in-the-blank things. And yes, there are different ways to write it, but this is the reason that I always keep it the same. So we're going to write this line right here as our first option. So in that first one, what did we do to the null hypothesis? In the one I circled, what did we do to the null hypothesis? So we reject the null hypothesis. Did we have a big p-value or a small p-value? So since the p-value is less than this alpha thing we haven't talked about yet, which means that we do have convincing evidence in the direction of the alternative hypothesis. So the reason I am very particular about wording it this way, we do reject because it is, so we do. Positive connotation, positive connotation, positive connotation. And it's a whole lot easier to remember than trying to like mix up your wording and all that kind of stuff. So here, if we don't reject, we what reject? Or we fail to reject the null hypothesis since the p-value is not less than alpha. So we do not have convincing evidence. Is it mathematically incorrect to say that here, at times, the p-value is greater than alpha? Is there anything wrong with saying p-value is greater than something instead? But do you see why I choose to write it this way? So it's fail to, not, or reject is do. And that's why I choose to write it exactly like this. And it saves a lot of confusion. So let's go back to where we started with the person running the very first scenario. So we ended up getting a p-value of about, so the front page, the bottom right-hand corner.
1.587.
Right? So we haven't talked about alpha yet. Most of the time we're going to use alpha equals 0.05. I'll make a big conversation about that. So for right now, let's just write.
Where are we writing this?
I'm just talking about the, I would probably write it somewhere down here. So this number is not less than this number. Everybody agree with me? 15% is not less than 5%. So let's write our conclusion. That means that we, what? Which are the two things we just wrote in the conclusion? Yeah.
So where did you get the 0.05 from?
Right now, I just wrote that down.
Oh, okay.
Yeah. Yeah, this should not make sense to you right now while I wrote that. So we failed to reject. What are we failing to reject? Which is the null hypothesis that mu equals 5 minutes. So we failed to reject the null hypothesis of this. Why?
Since p-value is not. Plus A. Oh, alpha.
Which again, why the world are we using that? Don't worry about it right now.
Then alpha equals 0.5.
And then our last sentence, we which way did I write it? Convincing?
Convincing evidence.
Sometimes people say convincing, some people say significant.
That
And then, so I could write mu greater than 5, but what is that in context? What does greater than 5 minute mean in context of running? So you should at least be able to get an idea of full picture of what it is that we're doing. The only thing that I pretty much overlooked is the alpha. Talking very generally about it really quick. This is something that we decide initially. Like we think it's okay to reject him if it only happens 5% of the time or less. Like that's what that is. And I think I talked about it in this class. If it were something like running, is something bad going to happen if I'm wrong that he doesn't run that slow or that fast? If it's something like clinical trials for a new drug and it might have some bad side effects, would we want to do something like it might not work 5% of the time? That's okay. We would probably change it to like 0.0001. So that's in general what this is where it comes from. But for our class, for the most point, we're either going to use that or I'm going to use